Here starts Lesson 9.4 Part B, where we'll take a look at a little bit more complex polynomials when we try to find common denominators. Now if you look at the first one here, okay, before it was pretty straightforward. 6x, 4x cubed, 12x cubed was the common denominator. The next one we're going to look at a little more closely, and before we do it, before we find out what the least common multiple is, we have to factor each one. And this one's different. These are different because they are binomials and trinomials. That would be our first clue to see if we can factor them. If we can't, that's fine, but we always want to check. So if we do factor this first one, we notice it's 5 m plus 3. So I factor a 5 away, or divide by a 5, we get m plus 3. The next one, we have 2 and m plus 3. Sorry, using my mouse again. Now, when you look at these two things, now is the question, what is the least common multiple? Or again, if I did this, if I made it a fraction, or two fractions, what's the common denominator going to be? Well, the 5 and the 2 are pretty straightforward. What can 5 and 2 both go into? And that's going to be 10. And now the m plus 3 is considered one thing. Just like we had x, or x cubed, m squared, t cubed, that's one thing. Well, because of the parentheses, this is considered one thing. It's a binomial. So that's its own piece. We can't just look at it separately and say, oh, it has an m, it has a 3. It is m plus 3. Notice that they both have m plus 3. So it's like they both had an x. Like up here, they both had an m squared and an m squared. So we had m squared in our common denominator. That's the same case here. This is our least common multiple, and if they were fractions, it would be considered the common denominator. Next one, notice again we have x plus 3, a binomial. It's not factorable, so it's as is. The first one, however, is a trinomial, so we automatically ask ourselves, is it factorable? Because we will need to do that, if it's possible. Factors, a product of 18, factors of 18 that add up to 9, which would be 6 and 3. Have to add up to a positive 9, so they're both positive. Okay, so then we have x plus 3. And I'm going to put it in parentheses because it is one piece. And I'll ask the same question. If this was a fraction with 1 on top, what's the common denominator going to be? So let's look at this. It's like saying 1 over AB and 1 over, now it's the x plus 3 was b, so I'll write b here. So they both have x plus 3. That's why this example here, they both have b's. What would the common denominator be in this case? Well, it looks like this first one has ab and the second one has just b. So I would take the second one times a to get a common denominator. So if you look down here, what would the common denominator be? Well, my common denominator would need an x plus 6, and it would need the x plus 3. And that would be the common denominator. In this case, the least common multiple. So what do they have in common? And what do they both need so that they are the same? So because we're looking at multiplying binomials to get common denominators, that makes our work a little bit more interesting, and we have to be a little bit more careful. Alright, so let's take a look at the first one here. Now I have a 3 and I have a b plus 2. The b plus 2 is one thing. So what does my new denominator need? It needs to have a 3 and it needs to have a b minus 2. That's my common denominator. So, like we did before, I have a b minus 2. What do I need to make it a 3 times b minus 2? I need to multiply by 3, top and bottom. Now I'll make that a 6. The second one needs a b minus 2. But I have to multiply top and bottom by that. Okay. Now, before I distribute the 4, because it's a binomial and you have to distribute, let's change this to, instead of subtraction, let's say we're adding a negative. And that's important because that helps us realize that we are actually distributing a negative 4. So that would give us a negative 4b plus 8. So now we would finish by adding like terms. I do not have to distribute this 3 in the bottom. I'm okay with just you leaving it as is in factored form. That's good enough for me, but if you wanted to distribute the 3 you could, but it wouldn't really do us any good. So I'm going to write the term with the variable first, and that's a negative 4b and 6 plus 8. That's our answer. Next one we have two binomials. So again, let's do this. We have a subtraction problem. I'm going to make it adding a negative instead. Just to clean it up a little bit, it takes care of little mistakes later. Now I have an a plus 4 in parentheses and an x plus 6 in parentheses, so my common denominator will need both an a plus 4 and an a plus 6. What's the first one need? Well, it has the a plus 4, but it needs the a plus 6. Now, this is a distribution question, so I will get 4 a squared plus 24 AB, or excuse me, 24a. That's a 6 there. Okay. The second fraction has the a plus 6, but it needs the a plus 4. So I multiply top and bottom by a plus 4, and we get a distribution of a negative 5, okay, which gives us a negative 5a minus 20. Now we next look and say, is there or are there any like terms? 4a squared does not have any other like terms. 24a minus 5a are like terms. That gives us a 19a minus 20. All over, and again you can just write out a plus 4. You don't have to FOIL it or anything. This is good enough. And that's good. Now the numerator could be factorable. It won't help us though, because I don't think it's factorable, but I think this is okay right here. But again, it is something to consider about factoring it to see if you can cancel anything else out, but I don't think you can. Alright, next ones we have 6, let's make that a fraction. Okay, now I have m squared minus 1. Now that is the difference of two squares. This is, like I said, a difference of two squares, but we wouldn't need to factor this because the other denominator is exactly 1, so the denominator is going to have to be m squared minus 1. So factoring it wouldn't help us per se in this particular case. But I will do this, plus a negative 6m. So that means the first one needs an m squared minus 1. That's going to be the common denominator. Well, that's pretty ugly. Alright, m squared minus 1 so we're going to distribute the 6, and that's going to give us 6m squared minus 6. Now the second one already has the common denominator, so I'm just going to write minus 6m. because there's nothing that needs to be fixed in the second fraction. There's no like terms, so officially you write 6m squared minus 6m minus 6 because that's standard form, but I'm just going to leave it like that right now, like it's written, and that would be good enough. Okay, the next one, we have a rational expression here with 4m squared, and the second one is a trinomial. So let's factor that and see if we can simplify this first. Now the last question, factoring that one out would not have canceled anything out, but this one it might. So let's just play around with that for a second. If we can factor this, maybe we can cancel this p plus 2 out. So let's see, factors of negative 12 that have a difference of 1, that'd be 4 and 3. And you want a plus 1, so when you add them together, and nothing cancels. Well, it didn't seem to help us any. I was kind of hoping that that p plus 2 would cancel with one of those, but it doesn't. So because nothing canceled out, it really wouldn't help us any to have this written that way. Okay, so let's just go ahead and approach it like this trinomial. Otherwise we have to redistribute and everything, so this is as good as it will get. So if we look at this, the common denominator will need the 4p squared and the p squared plus p minus 12. Again, this p squared here in the first fraction and the p squared in the second fraction are not the same ones because this is tied to the rest of the trinomial. So now the first fraction will need to be multiplied by the whole trinomial. Okay, but instead of me writing it all out here, I'm going to just write out the first one. Okay, so we have p squared plus p minus 12. So again, that's written down here too, but I just didn't write it out. Sorry about that, but my mouse is being a pain. But I have to distribute the 3. Okay, that will give us 3p squared plus 3p minus 36, and the second one I'm going to have to multiply both sides by 4p squared. Now remember, we have a negative, we're subtracting these two, so let's change this again. And I did that first last time. I should have done it first on this one, but it's going to be plus a negative. Plus a negative what? Well, that means this whole numerator is actually negative p minus 2. So I'm going to take this 4p squared and I'm going to distribute that to these two pieces. Okay, so that negative had to become a part of this. And last question I did it first, so I should have done it first here, but I'm sorry, I forgot that part. So it happens to me too. But I did catch it. The reason we do it first is hopefully we won't miss it and then make mistakes, but best to do it first. Okay, so now if I distribute that, I have a negative p times 4p squared, which is a negative 4p cubed, and then a negative 8p squared. And that's all over the common denominator. Now before I write that common denominator down again, I'm going to combine like terms. I have negative 4p cubed, that's the biggest one, so I'm going to put it in standard form. That would go first. That's this one. And then I have a 3p squared and a negative 8p squared. So together, that's a negative 5p squared. Okay, that's those two. And then I have a plus 3p. And then I have a minus 36. And the denominator is 4p squared parentheses p squared plus p minus 12. And again, I don't need to distribute that in the denominator. It just shows what the denominator is, and that's good. So this would represent the result of subtracting those rational expressions. So this ends the second part of lesson 9.4.